we are working with comparing fractions using word problems, okay? So it's not going to be anything that is going to be crazy or different. It's just comparing fractions using the word problem. So we're going to pull the fractions out of our word problems. So this one says, write the fractions and then compare. Greg ate 2/6 of his sandwich. Janie ate 4/6 of her sandwich. Who ate more of their sandwich? Draw and explain. Okay? Simple. Let me show you. Greg ate 2/6, so there's one fraction. Janie ate 4/6, there's another fraction. So I'm going to compare 2/6 and 4/6. Okay? I can draw a fraction bar to show you that. So let me show you how that's going to work. Now, the key when you're drawing this fraction bar is to make sure you draw the two bars how? Equally. Because if you got one bar that's longer than the other, that is not going to work. Okay, so 2/6. So both of these fraction bars are going to be divided into 6. So 1, 2, 3, 4, 5.
It has to be the same like the lines.
Yep, they have to be matched up because they're be equal. Okay, so it says Greg ate 2/6. I'm going to color in 2/6. And then it said that Janie ate 4/6. I'm going to color in 4. Now, looking at our picture, who ate more? Carly?
Jane.
Janie ate more. She ate 4 out of her 6 pieces. So that's the greater fraction.
Because they're both even.
Well, they're not both even, but they are both dividing the same parts. Do you have a question? What's your question?
How is it for 6?
That's what it gave us. But there's 4 parts. There's 2. He ate 2 here. She ate 4. 4/6 will be closer to our whole. But I can cross multiply to check. 6 times 2 is 12. 6 times 4 is 12 is less than
24.
24. So 4/6 is our greater fraction. Gerard?
I thought you supposed to pick the I thought you supposed to pick like the littlest thing.
Let's pick what?
The littlest number.
It said who ate more though?
Oh, that means who ate like the
Who
most.
ate the most? And when we have fractions that have the same denominators, like denominators, we look at the numerator. The greater the numerator, the greater the fraction. Okay? 4 is bigger than 2. 4/6 is our greater fraction. Okay?
Yes, ma'am.
So let's move on if there's no more questions about this one. So, CJ ran 3/4 of a mile. Beckham ran 1/4 of a mile. Who ran more? So, we're comparing 3/4 and 1/4. Same denominator. What's the rule?
Look at the denominator.
Look at the denominator.
If the denominator is the same,
Look
look
at
at the numerator. The greater the numerator, the greater the fraction. Which has the greater numerator?
3/4.
3/4.
I got it right.
So 3/4 is our greater fraction?
Yes.
So who ran more miles?
DJ.
That's CJ did. Let's go do cross multiplication just to check. 4 times 3,
12.
12. 4 times 1,
4.
And I could draw this. I can put this on a number line.
So he ran 12 miles. But he ran.
Here's 1/4. Here's 3/4. Who ran the greater mile?
CJ.
CJ.
Because he's closer to the home.
Closer to the hole. Okay?
Yes.
We're good? Thumbs up?
Yeah.
Okay, let's move on then. candy. 3/8 of the pieces of candy were sour. The rest were sweet. Are there more sour or sweet pieces of candy? Draw and explain. Okay? So we are comparing 3/8. Well, that's how many he had. So let me go ahead and draw that out. So I divided it into 8. 3/8 were sour. The rest were sweet. So this is the rest. How much is that? 5 what?
5/8.
5/8.
8.
So
5/8 were sweet and 3/8 was sour.
So our question says, are there more sour or sweet pieces?
More sweet.
There's more sweet pieces. We have 5/8 that's sweet, so that's the greater fraction. That's more than we have.
Because 5 times 8 equals 20. Yeah, that's right.
Okay? With thumbs up, thumbs down. Okay, moving on. Kim ate 1/4 of her pizza. Her brother ate 1/2. The pizzas are the same size. Who ate more of their pizza? So she ate 1/4.
Yeah,
Her
half.
brother ate 1/2. Who ate
Count, count,
It was half.
count.
Her brother ate 1/4.
Hold on.
Her brother ate 1.
Her brother ate more. Why?
Oh, because he ate 1/2.
Carly, why?
Because the denominator is smaller, which makes the pieces bigger.
That's true. But what do we know about 1/2? It's also
Oh.
equal to
Oh!
not 1/4. It's 2/4.
Because you got the he ate half of the pieces, so that I mean half of the pieces gone.
Yes, half the pizza is gone. So 2/4 is greater than 1/4. So therefore 1/2 is greater than 1/4. So he ate more. Okay? Thumbs up? I'm not sure. Some of y'all are not letting me know. Thumbs up? Moving on, if there's no questions, then. Okay, the track team jogged for 3/8 of a mile in the morning. In the afternoon, they jogged 3/4 of a mile. Did they jog longer in the morning or in the afternoon? So for the morning time,
Afternoon, I think.
for the morning time it said 3/8. For the afternoon it said 3/4. What's the rule? When the numerator is the same, look at the denominator. The greater the denominator, smaller the fraction. So when did they run more? When they jogged
No
more?
morning.
Afternoon.
In the afternoon. 3/4 would be greater than 3/8. 4 times.
It's 12. That is 24.
When the numerators are the same, Sherrod, you look at the denominator. The greater the denominator, the smaller the fraction. So that means that 3/4 would be bigger than 3/8.
I don't get it. I don't get the question.
Did they jog longer in the morning or in the afternoon? They jogged longer in the afternoon. 3/4 is more.
Guess I asked questions.
Okay? So 3/4 and then 3/8. So who would have jogged more?
In the morning.
This is morning, this is afternoon.
Afternoon.
The afternoon. See it? You understand?
No, cause I'm getting confused by the 8.
Okay, listen to me again. When the numerators are the same, we look at the denominator. The greater the denominator, the bigger the denominator, the smaller the fraction, because the more parts you cut, the smaller those parts get. Remember I told you about the cake? And how many people you should invite to your party? Because the more people you invite to your party, the smaller your piece of cake is going to get. That's the same thing. 8 may be bigger, but it's going to be a smaller part, a smaller section. Joy?
If you have, since you have an 8 and a 4, when you have an 8,
Do you have a question?
Nope.
Okay, then let's move on. Okay, after softball, Leslie and Kelly each bought a half-liter bottle of water. Leslie drinks 3/4 of her water. Kelly drinks 3/5 of her water. Who drank the least amount of water? So we're comparing 3/4 and 3/5.
It said that Kelly eats by half liter.
Yeah, they bought a half-liter of water. That's not how much they drank. So think of like a liter of Coke. And then they're drinking like, she drank 3/4 of her Coke, and then he drank 3/5 of his Coke. But it's water. Sorry.
Kelly drink less water.
Kelly did, yes. Because 5 is, so 3/5 is the smaller fraction.
Oh yeah, because now get it. Well,
If
three times 5, you can see.
Who doesn't get it? Did you? Who said they didn't get it?
It's over here.
Okay. The rule for fractions, y'all. Remember this. 3/4 and 3/5. When the numerators are the same, we look at the denominator. Okay? The greater the denominator, the smaller your fraction. That doesn't matter that 5 is bigger than 4. Doesn't matter, we're talking about fractions. There's 3/4. And then here's 3/5. Okay? This 3/4 is the greater fraction, but it said who drank the least amount of water? That'd have been Kelly because she drank 3/5.
Oh.
We good?
Yes.
Are we sure?
Yes, ma'am.
Okay, now let's move on. Becky and Mallory get matching piggy banks. Becky fills 2/3 of her piggy bank with pennies. Mallory fills 2/4 of her piggy bank with pennies. Whose piggy bank has more pennies? So we're comparing 2/4 and 2/3. Same numerator.
Look at the denominator.
So who is it? Whose piggy bank has more pennies? Amani? Does Mallory's, Mallory, no. Does Mallory's piggy bank have more?
No.
2/3.
When the numerators are the same, Amani, look at the denominator. The greater the denominator, the smaller the fraction. So whose piggy bank has more? Becky's. 4 is bigger than 3, but we don't care about that when we're talking about fractions.
Ain't 2/4 is 1/2?
No, it's 1/2.
Oh.
So let me draw it out for you. Here's 2/4. Here's 2/3. 2/3 is the greater fraction. Okay? We good?
Yes.
For sure? I don't know. Some of y'all are not letting me know. Okay. Let's see. Should be the last one we got. Heidi lines up her dolls in order from the shortest to the tallest. Doll A is 2/4. Doll B is 2/6. And doll C is 2/3.
How we gonna do that?
Simple.
2/3, 2/4, 2/6.
So from the shortest to the tallest.
2/3, 2/4, 2/6.
So here is 2/3. Here is 2/4. And then here is 2/6. So who is the shortest?
2/3.
Y'all are not looking. Who has the shortest?
2/6.
2/6. And then
2/4 and then 2/3. Is that biggest to the smallest?
the shortest to the tallest.
So how is 2/6? But 2/6 is bigger.
It's not bigger. What's the rule for numerators? If the numerator's the same, look at the denominator. Here's 2/6. Here's 2/4. Here's 2/3. The bigger the denominator, the smaller the fraction. 6 is bigger than 4 and bigger than 3. Adonis?
Aren't you supposed to put the 6 on top of the 2, which has 2/4? And aren't you supposed to put the 4 at the one that has 6?
Am I supposed to do what?
Aren't you supposed to put the 6 on top of the 2?
Why would I put the 6 on top of the 2?
6, 2.
The fraction's 2/6. 6 is how many parts you have. 2 is the number of parts being counted. The denominator is 6. Denominators go on the bottom. Joy?
No, if you, I'm just saying, but if you had the 6 on top, would you have 6,
6 halves would be an improper fraction. And we're not talking about improper fractions right now. Okay? Are there any questions?
no, no.
Okay.